Constraints-based learning, application to tennis. Constraints-based learning is part of the ecological dynamics that identifies key properties in the sport based on the player-environment relationship. In case the tactical concepts of the game and the fundamental movement patterns. Constraints consider learners, teams, and athletes as adaptive systems that learn by adapting the constraints of the environment. They influence the tasks they are performing. They also are classified into three distinct categories: the player or learner, task, and environment. Constraints can be the learner's body, experiences, attitude, as well as task, rules, equipment, intent, or environmental area of play in the conditions. And constraints-based learning studies how the interaction of constraints shapes the degree of freedom in learning within a nonlinear process. So when we look at constraints, the environment constraints is initially how we set up, but then we look at the idea of the player constraints. So the intent within the learning is to provide a landscape of available affordances, such as smaller tennis courts, slow bouncing balls, and gradually increase the challenge of tasks that supports the emergence of functional adaptive movement behavior. So the task becomes a way of mediating the player into that environment. So in this sort of setup, the teacher gives input to set up the task that will help the learner, the player, develop goals and structures as they enter into the environment. So it will look like a modified game based on tennis, but with exaggeration rules to focus on a tactical problem or skill solution. For example, the teacher might demonstrate the task with a partner saying, serve the ball from hand, rally with your partner in this small court, 4 balls in a row, and then try to win the point. First to win 4-point wins. In motor learning, this is called a representative learning design. As you move from the task into the environment, now the players are interacting with the environment in order to help them search for solutions to the challenges set by the task. These challenges can be set up as a problem to solve. Like the example, how do we keep the ball in the court for 4 times in a row becomes the initial problem. Key here is the functional exploration, laying a foundation of variation in initial learning for the player. As the environment constraints works, as the player engages in the task, they're encouraged to search for enabling actions that help them to achieve the task. This represents a coordination of the player movement exploration to a task environment interaction, sort of perception action coupling, and can be facilitated by teacher questioning or pointing out good examples of success. This cycle continues. The teacher extends the questions by actually asking a whole set of students, where do you go after studying the ball? As players learn to retreat behind the back line of the court to play the next shot, this can be highlighted by the teacher as a possible solution, asking players why this helps. As players start to realize, they can see the whole court and are able to cover the court and move forward to the ball that's been sent. As the players go through this process, they act on the task. The task focuses them on affordances to achieve the task, what the environment offers, such as in this case, repositioning in the court after playing a shot. As players engage with their partner, they also see solutions to the problem and start to adjust their moves to gain control of the ball after the initial period of coordination. It's this linking between what the player sees and what they understand, what they see and what they do. As players start to show some form of control over the ball, the teacher can focus on task development, offering skill elements that will help the players execute the skill that addresses the problem set by the initial game task. Through task simplification, the teacher can then present simple cues related to the initial game in a series of progressive tasks going back to that initial game. For example, how to make impact with a ball at a comfortable distance from the body at waist-knee height. Task simplification with goals to aim for can create a progression such as modeling of cues, partner feeding the ball, and then rallying with a self-rally modification before return to the game. This helps bridging the gap between a simple drill and a complex game. With tasks simplified to match the individual technical ability of the players, then progress is made. As players repeat these skill cues, they engage in a process of repetition without repetition, building gradual success in their search for optimal modal solutions to the task problem. In this process, players become attuned to the affordances in the practice environment as it connects to their previously played game environment. Hence, the skill starts to emerge. As you look at this whole process, the key element is that players' degree of freedom in addressing the problem is the key in their learning. They're acquiring the skills, but they're also acquiring their ability at the foundation of those skills. Players are then able to repeat addressing a problem such as rally the ball in tennis by continually solving it in different ways as the environment constraints become more challenging. The court gets bigger, the ball gets faster. In this sort of model, the key element at the beginning is very structural between the player and the task. The constraint-based learning shows that how the player practice then play approach is initially a structural process where the players are offered an action space to engage in. They must search for solutions, engaging them in a complex adaptive system where their cognition, capacity to think, is adaptive to the constraints of the context that influences task performance. As they do this, teacher needs to provide an activity of available affordances focused on by the design of the task. That supports the emergence of functional adaptive behaviors. Students start to realize what they do to help them achieve the task and therefore become more successful in the game. As they move from engaging with the environment, players learn to self-regulate by developing and exploiting their intertwined relationship between what their actions do, what they perceive, their intentions, their emotions, and they continue to support their emergent interaction in relation to the environment that supports these processes. As they play the game, they start to figure out how to be more successful. So here you have the key is developing a constraints-based learning in playing practice play approach is that the players learn to become attuned to affordances in similar environments. Then they can continuously transfer their movement solutions from one environment to more complex ones related to the target full game. In this approach, the teacher input, in contrast to traditional isolated practice or drills, the environment is very static and learning is limited to the focus applied by the coach or teacher. With constraints-based learning, the environment is dynamic. Players are constantly invited to engage and search for perceptual cues, allowing them opportunities to maximize their learning. Key in instructional process is to help the search process of the player. For the instructor, the idea is anticipating moments for when to add in technical prompts, examples, questions, or models to draw on to add to the player's emerging learning. Practice then becomes repetition without repetition, where players can use the emerging movement pattern to address the same problem in the same environment and continually search for more refined movement solutions. Thank you for listening. Links to resources for additional conversation around this idea or constraints-led approach. Thank you.